Sergeant Major Koa asked thoughtfully, "Sir, would it do the Connie much good to launch boats this close to the sun? They'd have to use too much fuel just keeping position." "You could be right," Rip said slowly. Koa had a point. To counter gravitational attraction took velocity, which meant consumption of fuel. Maneuvering boats meant rapid velocity changes. Against the sun's terrific gravity at this distance, it also meant maximum thrust and maximum fuel flow most of the time. The asteroid, in a planned orbit with the correct velocity, was safe enough, and the Connie cruiser would simply match the asteroid's orbit. But boats, which had to maneuver, were another matter. Rip figured quickly. In accordance with Newton's law, gravitational attraction increased rapidly on approaching a body. If he could put the asteroid even closer to the sun, the boat problem would become worse, until even a small velocity change in the wrong direction could leave a boat in the terrible position of not having enough thrust for a long enough time to keep from being drawn into the sun. But to change the asteroid's orbit was dangerous. It meant losing just enough velocity to be drawn closer to the sun, and then picking up a much higher velocity to get free again. Rip got his instruments and pulled out a special slide rule designed for use in space. He had Koa stand by with stylus and computation board and take down his figures. He recalculated the safety factor he had used when deciding how close to the sun to put the asteroid, then took quick star sights to determine their exact position. They were within a few miles of perihelion, the point at which they would be closest to Sol. Rip tapped gloved fingers on his helmet absently. If they could blast out of the orbit and drive into the sun, he estimated the result. A few miles per second of less speed would let them be pulled so far within the sun's field of gravity that, within an hour or so, small boats would venture into space only at their peril. He reviewed the equipment. They had tubes of rocket fuel, but the tubes wouldn't give the powerful thrust needed for this job. They had one atomic bomb. One wasn't enough. Not only must they drive toward the sun, but also they must keep reserve power to blast free again. If only they had a pair of nuclear charges. He called his Planeteers together and outlined the problem. Perhaps one of them would have an idea. But no useful suggestions were forthcoming until Domenico spoke up. "Sir, why don't we make 2 bombs from one?" "I wish we could," Rip said. "Do you know how?" "No, Lieutenant. If we had parts, I could put bombs together. I can take them apart, but I don't know how to make 2 out of one." The Italian Planeteer looked accusingly at Rip. "I thought maybe you knew, sir." Rip grunted. If they had parts, he could assemble nuclear bombs, too. Part of his physics training had been concerned with fission and its various applications. But no one had taught him how to make 2 bombs out of one. The theory behind this particular bomb design was simple. 2 or more correctly sized pieces of plutonium or uranium isotope, when brought together, formed what was known as a critical mass, which would fission. The fissioning released energy and produced the explosion. But there was a wide gap between theory and practice. A nuclear bomb was actually pretty complicated. It had to be complicated to keep the pieces of the fissionable material apart until a chemical explosion drove them together fast and hard enough to create a fission explosion. If the pieces weren't brought together rapidly enough, the mass would fission in a slow chain reaction with no explosion. Rip was trained in scientific analysis. He tackled the problem logically, considering the design of a nuclear bomb and the reasons for it. Atomic bombs had to be carried. That meant an outer casing was necessary. The casing had a lot to do with the design. Suppose no casing were required? What would be needed? He took the stylus and computation board from Koa and jotted down the parts required. First, 2 or more pieces of plutonium large enough to form a critical mass. Second, a neutron source, the type of radioactivity that produced neutrons, to accelerate the reaction. Third, some kind of neutron reflector. And fourth, explosive to drive the pieces together. Did they have all those items? He checked them off. Their single 5 kT bomb contained at least enough plutonium for 2 critical masses, if brought together inside a good neutron reflector. Each mass should give about a 2 kiloton explosion. And they did have a good neutron reflector, nuclide. There wasn't anything better. What have we got for a neutron source? He asked aloud. He was really asking himself, but he got a quick answer from Koa. Sir, some of the stuff left in the craters from the other explosions gives off neutrons. You're right, Rip agreed instantly. A small piece from one of the craters, when combined with half of the neutron source in the bomb, should be enough. As for the explosive, they had exploding heads on their attack rockets. In other words, he had what he needed except for a method of putting all the pieces together to create a bomb. If only they had a tube of some sort that would withstand the chemical explosion, the one that brought the critical mass together. He told the Planeteers what he had been thinking, then asked, "Any ideas for a tube?" "How about a tube from the snapper boat?" Santos suggested. Rip shook his head. "Not strong enough. They're designed to withstand the slow push of rocket fuel, not the fast rap of an explosion. When I say slow, I mean slow burning when compared with explosive." "Any more ideas?" Kemp, the expert torchman, said, "Sir, I can burn you a tube into the asteroid." Rip grabbed the Planeteer so hard they both floated upward. "Kemp, that's wonderful." "That's it." The details took form in his mind even as he called orders. "Domenico, tear down that bomb. Santos, remove 2 heads from your rockets and wire them to explode on electrical impulse. Kemp, we'll want the tube just a fraction of an inch wider than a rocket head. Get your torch ready." He took the stylus and began calculating. He talked as he worked, telling the Planeteers exactly what they were up against. "I'm figuring out where to put the charge so it will do the most good, but my data isn't complete. If our homemade bomb goes off, I don't know exactly how much power it will give. If it gives too much, we'll be driven so close to the sun we'll never get free of its gravity." Bradshaw, the English Planeteer, said mildly, "Don't worry, Lieutenant. If it isn't the solar frying pan, it's Connie fire." A chorus of agreement came from the other Planeteers. What a crew! Rip thought. What a great gang of space pirates! He finished his calculations and found the exact place where Kemp would cut. A few feet away from the spot was a thick pyramid of thorium. That would do, and they could cut into it horizontally instead of drilling straight down. He pointed to it. "Let's have a hole straight in for 6 feet. And keep it straight, Kemp. Allow enough room for a lining of nuclide. Koa, cut a sheet of nuclide to size." Kemp's torch already was slicing into the metal. Rip asked, "Can you weld with that thing, Kemp?" "Just show me what you want, sir." "Good." Rip motioned to Trudeau. "Frenchie, we'll need a strong rod at least 8 feet long." The French Planeteer hurried off. Rip consulted his chronometer. Less than 10 minutes had passed since the call from Terra Base. He went over his plan again. It had to work. If it didn't, asteroid and planeteers would end up as subatomic particles in the Sun's photosphere, because he had calculated his blast to drive the asteroid past the limit of safety. It was the only way he could be sure of putting them beyond danger from Connie landing boats or snapper boats. The Connie would have only one chance, to bring his cruiser down. If he tried that, Rip thought grimly, he would get a surprise. The second nuclear charge would be set, ready to be fired. The Connie cruiser was so big that no matter how it pulled up to the asteroid, some part of it would be close enough to the charge to be blown into space dust. No cruiser could survive an atomic explosion within 500 yards, and the Connie would have to get closer to the nuclear charge than that. Domenico reported that the bomb had been dismantled. Rip went to it and examined the raw plutonium, being careful to keep the pieces widely separated. This particular bomb design used 5 pieces of plutonium which were driven together to form a ball. Rip made a quick estimate. 2 were enough to form a critical mass. He would use 2 to blast into the Sun and 3 to blast out again. He would need the extra kick. There was only one trouble. The pieces were wedge-shaped. They would have to be mounted in thorium in order to keep them rigid. Only Kemp could do that. They had no cutting tool but the torch. Santos appeared, carrying a rocket head under each arm. They had wires wound around them, ready to be attached to an electrical source. Rip hurried back to where Kemp was at work. The private was using a cutting nozzle that threw an almost invisible flame 5 feet long. In air, the nozzle wouldn't have worked effectively beyond 2 feet, but in space it cut right down to the end of the flame. Kemp had his arm inside the hole and was peering past it as he finished the cut. "Done, sir," he said, and adjusted the flame to a spout of red fire. He thrust the torch into the hole and quickly withdrew it as pieces of thorium flew out. A stream of water hosed into the tube would have worked the same way. Rip took a block of plutonium from Domenico and handed it to Kemp. "Cut a plug and fit this into it. Then cut a second plug for the other piece. They have to match perfectly, and you can't put them together to try out the fit. If you do, we'll have fission right here in the open." Kemp searched and found a piece he had cut in making the tube. It was perfectly round, ideal for the purpose. He sliced off the inner side where it tapered to a cone, then, working only by eye estimate, cut out a hole in which the wedge of fission material would fit. He wasn't off by a 32nd of an inch. Skillful application of the torch melted the thorium around the wedge and sealed it tightly. Koa was ready with a sheet of nuclite. Trudeau arrived with a pole made by lashing 2 crate sticks together. Rip gave directions as they formed a cylinder of nuclite. Kemp spot welded it, and they pushed it into the hole. Nunez found a small piece of material in one of the earlier craters. It would provide some neutrons to start the chain reaction. Rip added it to the front of the plutonium wedge, along with a piece of beryllium from the bomb, and Kemp welded it in place. They put the thorium block which contained the plutonium into the hole, the plutonium facing outward. Trudeau rammed it to the bottom with his pole. The neutron source, the neutron reflector, and one piece of fissionable material were in place. Kemp sliced another round block of thorium out of a nearby crystal and fitted the second wedge of plutonium into it. At first Rip had worried about the 2 pieces of plutonium making a good enough contact, but Kemp's skillful hand and precision eye removed that worry. The torchman finished fitting the plutonium and carried the block to the tube opening. He tried it, removed a slight irregularity with his torch, then said quietly, "Finished, sir." Rip took over. He slid the thorium-plutonium block into the tube, took a rocket head from Santos, and used it to push the block in farther. When the rocket head was about 4 inches inside the tube, its wires trailing out, Rip called Kemp. At his direction, the torchman sliced a thin slot up the face of the crystal. Rip fitted the wires into it and held them in place with a small wedge of thorium. Kemp cut a plug, fitted it into the hole, and welded the seams closed. The tube was sealed. When electric current fired the rocket head, the thorium carrying the plutonium wedge would be driven forward to meet the wedge in the back. And, unless Rip had miscalculated the mass of the two pieces, they would have their nuclear blast. Rip surveyed the crystal with some anxiety. It looked right. Domenico already had rigged the timer from the atomic bomb. He connected the wires. "Do I set it, sir?" "Load the communicator, the extra bomb parts, the rocket launcher and rockets, the cutting equipment, my instruments, and the tubes of fuel," Rip ordered. "Leave everything else in the cave." The Planeteers ran to obey. Rip waited until the landing boat was nearly loaded, then told Domenico to set the timer for 5 minutes. He wondered how they would explode the second charge, since they had only the one timer left, then forgot about it. Time enough to worry when faced with the problem. "I'll take the snapper boat," he stated. "Santos in the gunner's seat. Koa in charge in the landing boat. Doused pilot. Let's show an exhaust." He fitted himself into the tight pilot seat of the snapper boat while Santos climbed in behind. Then, handling the controls with the skill of long practice, he lifted the tiny fighting rocket above the asteroid and waited for the landing boat. When it joined up, Rip led the way to safety. As he cut his exhaust to wait for the explosion, he sighted past the snapper boat's nose to the asteroid. Even though both boats had been careful to match velocity with the asteroid as closely as possible, the slight difference remaining caused them to drift sunward. Rip cut his jets in to compensate, and saw Doust do the same. Another few miles toward the sun, and the landing boat wouldn't have the power to get away from Sol's gravity. A few miles beyond that, even the powerful little snapper boat would be caught. Below, the timer reached 0. A mighty fan of fire shot into space. The asteroid shuddered from the blast, then swerved gradually, picking up speed as well as new direction. Rip swallowed hard. Now they were committed. They would reach a new perihelion far beyond the limits of safety. P for perihelion and P for peril. In this case, they were the same thing.